I provide you with cosine of theta equals 5 over 11. Now, in your notes last class period, you know that 5 over 11 for cosine represented the adjacent over the hypotenuse, correct? And we know, and they're asking us to find the remaining 6 trigonometric functions. So if I'm going to be finding sine or if I'm going to be finding tangent, that means I need to know what the opposite side is, right? I only have adjacent and hypotenuse. So what I'm going to do is I'm just going to create a triangle. And I'll just say theta's here. It doesn't really matter where you put theta. And I'll say here's my adjacent and here's my hypotenuse. So I'm just kind of creating this for a visual effect. And by this point now I say, oh, OK, well, I need to still figure out this side length. So therefore, I'm going to have to use Pythagorean theorem. And I'll just call this x. So therefore, I have 121 equals 25 plus x squared minus 25 minus 25. And that's going to give me 96. Is everybody following me with my Pythagorean theorem from geometry? Then you take the square roots. Now, you could say you're introducing the square root, so you have to do plus or minus. But we have to think about this in the context of the problem. Does it make sense in this current point for us to have a negative side length? No, because we just have a random triangle, right? So therefore, x equals the square root of 96. However, in this class, we're going to be doing some practice on this at the end of the class period. We always want to make sure we can simplify radicals, OK? So I know that 4 is divisible into this. 4 is a square number. And then let's look into 16. 16 times 6. What about 36? 72? No. So 16. So 16 times 6, you said? Yeah, yes, that sounds right. So x equals the square root of 16 times 6.
That breaks into 3 and 2 and 4 and 1 and 2.
So you could use factorization, stuff we talked about in.
4 radical 6.
Or you can just take the separate of these. Again, if you're a little bit weak on this from Algebra 1 and Algebra 2, we'll be doing some more practice on these today. So therefore, my height is 4 radical 6. So now, I was given my information. I applied it to a new situation with a triangle. Now I have all the side lengths of a triangle. Now, is it much easier for me to find sine, cosine, tangent, cotangent, cosecant, and secant?
Wow.
Yes, right? Sine of my theta is opposite over hypotenuse. So that's going to be 4 radical 6 over 11. Tangent of my angle theta is opposite over adjacent, 4 radical 6 over 5. Let's do the reciprocals of each of these. Secant of theta is the reciprocal of this. Or we could say that's hypotenuse over adjacent, so that's 11 over 5. Cosecant of theta is the reciprocal of sine. So that's going to be 11 over 4 radical 6. And cotangent of theta is the reciprocal of tangent, or it's adjacent over opposite in your notes. So that is 5 over 4 radical 6. But remember, what we're going to be practicing a lot, and you'll get a lot of practice in this today, is we always want to write our answer without the radical in the denominator. So we're going to multiply by our radical. And these are the only problems where the radical is in the denominator. So that's why I only have to rationalize these two. So here my final answer is 11 square root of 6. Square root of 6 times square root of 6 is 6. 6 times 4 is going to be 24. Over here, I have 5 radical 6. Square root of 6 times square root of 6 is 6. 6 times 4 is 24. And that's what you were expected to do for your homework. So for the remaining portions of the problems,